I will demonstrate you the use of up and down counter using the function blocks. Using the function blocks. For initializing these blocks or counting the pulses to those blocks, a digital input would be used. Now this digital input would be physically in the form of a photoelectrical switch or a limit switch, which will be connected to the counter either up or down. For demonstration purpose, I will simultaneously demonstrate up and down counter. So let me choose up counter and place it here, release here, and then take a down counter and release here. So now I can now give same pulse to up counter as well as down counter. The meaning of this is, if up counter is in the incremental form, this accumulator will go on incrementing, while in case of a down counter, this accumulator will go on decrementing. The main difference is, once you load the up counter and the down counter, accumulator of the up counter initially becomes 0, while the accumulator of down counter initially becomes equal to the preset value. So let me configure this, right click, configure, and for example, the description is CTU, that is up counter, and number of counts I want to count 5. So submit. Similarly, configure down counter. This is CTD and the description is 5, and I'll submit. Now I have submitted this. The moment I compile this, and if the logic is correct, there are no compilation errors, run will start. So you will find here that now if I run this, up counter accumulator has become 0, while down counter accumulator has become 5. Now I will give a pulse as if the object is past cutting the optical. Let me do this, toggle. So the moment I have toggled, this accumulator has become 1, this accumulator has become 4, means the down counter has started performing its work and the up counter has started work. So now if I withdraw this pulse, it's become 0, but as the pulse is just withdrawn, every time whenever that high rising pulse comes, only then the accumulator will be incremented or decremented. Now here I'll give another pulse. So this has become 2 and this has become 3. If I give this pulse again, nothing will happen. This will become 0, but this will remain at 2 and 3. Let me go on doing this. You will find that this accumulator has become 3, then the accumulator has become 4, and accumulator has become 5 after I give this pulse. Now the meaning of this is, this accumulator is equal to preset, so the output has become high. Whereas this accumulator is 0, you need one more pulse to make this down counter output equal to 1. So I have to withdraw this pulse. If I withdraw this pulse and if I give one more pulse, you will find output has become 1, but the accumulator has become -1. This indicates that the down counter is taking a pulse, which is when accumulator is equal to 0, output will not become 0, but accumulator is less than the preset, then and only then the output becomes 1 or high. So let me withdraw this. Now what will happen? The accumulator will go on incrementing and this down counter will go on decrementing. Now why this is happening? Because we have not resetted the counters, which is a mandatory requirement. So you can go to the reset instruction, configure the reset instruction and give the reset instruction address equal to upctr or dwctr, so that that particular counter will get resetted. Accumulator will become 0 for up counter. Accumulator will become equals to preset value in case of a down counter, and then you can start using these counters again for the next application. This is all about up and down counter. You can devise your own mechanism to find applications associated to the up and down counter.